We're looking at our unit of study on understanding equivalent fractions. In this unit, students learn that equivalent fractions name the same amount by using different size fractional parts. They begin with models only. Here they fill in 2/4. Here they make their own equivalent fraction. And now we start introducing numbers. Students become responsible for entering their own fractions. In the second week, students work with comparisons. And they learn that in some cases, fractions are equivalent, and in some cases, they're not. Here, 2 equivalent fraction models. Here, 2 fractional numbers that are not equivalent. Place them in the bins and choose the right operator. Students learn with a number line that more than one fraction can name the same point on the number line. 3 different fractional names are all equivalent to 1/4. So by the end of 2 weeks, students have learned a great deal about equivalent fractions. In the third week, they learn that there's a procedure for finding equivalent fractions, and it has to do with the one fraction. We start with the language of equivalent fractions. We talk about a second fraction having 2 times as many equal parts and 2 times as many shaded parts. Students work with this a lot. And then they move on to actually using names of 1, 3/3, 2/2, 3/3. And what they're doing is they're discovering that by using a one fraction, they're renaming and finding equivalent fractions. So that by the end of the third week, their number sense around equivalent fractions is very strong, and they can simply write an equivalent fraction. In the fourth week, students learn that a fraction can have more than one equivalent. 4/6, 2/3, 6/9, they're all equivalent. They work with models and numbers. They use different one fractions. And eventually they come to a place where they understand independently that 3/5, for example, can be expressed 2 different ways. Throughout this month of study, students are working with tool investigations, including the use of the unitizing grid, perfectly suited to the study of equivalent fractions. In this example, the red equals 1, and therefore the green can be described as 1/2. Why, these other colors, they're also 1/2, but we can use different fractions to describe them because they're equivalent fractions. Students also work with story problems. Here we have a story problem about a teacher with a class of 24 students. 1/8 of them are absent on a specific day, so we can express that in terms of 24ths. Students make their own story problems, and they use models, modeling with mathematics, attending to precision. This month of study culminates with a real-world investigation where students apply their knowledge of equivalent fractions to running a chocolate company. In this example, white chocolate will constitute 1/6 of the box, and the box will either have 12, 24, or 36 pieces. So there'll be different numbers of chocolate pieces, but with the same fractional equivalence. And students can decide what's the fractional amount of white or dark chocolate, and how does that represent itself in different size boxes. By the time they're done with this real-world application, they've created their own candy company with boxes of their own choosing, and they're putting equivalent fractional amounts in those different size boxes. So as the month comes to an end, students have learned that equivalent fractions name the same amount by using different size fractional parts, and they apply that understanding to their own personal lives.